Okay, so I will share my screen. My screen is visible, right? All of you.
Yes.
So give me a second. Okay. So today we will cover Kubernetes Ingress. Okay. Anyone heard about Ingress? Before that, today we go through the lab for Ingress, right? So uh, we need to configure Kubernetes. Okay. Before jumping to the theory, first I will set up a Kubernetes cluster. So I'm going to create a cluster. Okay. We all the dependencies are installed on this machine. Okay, like ekctl, kubectl, and all. Okay, now I am going to install Kubernetes. Okay, using ekctl. Ekctl create cluster. Name of the cluster. Then the region. Use is to one. Then node type. I will go with T2 small. Then how many nodes? Three is fine. Okay. So it will create the cluster. So we can jump into the theory part. So anyone heard about Ingress coming to Kubernetes? Any idea? All of you? Not really. Okay. Ingress actually one of the resource, okay, Kubernetes resource. So why we need to know first why we using Ingress, okay, when coming to a typical Kubernetes application deployment. So before that, I will draw a diagram, okay. So before how we will deploy application using Kubernetes. Okay, I will draw that diagram. For example, we have a application, Kubernetes application, okay. My pen is not working sometimes, okay. Okay, fine. So we have some application, okay, belongs to Kubernetes. So consider like that two pod. This is a pod one and this is a pod two. And both pod have same application, okay. App one and app one, A1 and A1. Multiple instances of application running on two pod, okay. So how we will access or how we will expose this application in Kubernetes? We have to create a service.yaml, right? So we need to define the service. So consider like that we have a service file for the same. So there will be create a service for exposing the application, and inside the service we need to define the service type as load balancer, right? So we will get a load balancer. I mean, if this is a AWS based one, okay, AWS EKS, then it will create, okay, that EKS will create automatically a load balancer for us, leveraging that elastic load balance, okay, that available. I mean, AWS will provide that load balancer, okay, elastic load balancer coming to EKS. So in this case, we will get a load balancer and that load balancer DNS as well to access the application. So any of the user, okay, this is an end user. So the user typing the load balancer, right? Or any domain name. So it will directly hitting to the service load balancer, and the load balancer take that request and distribute or sending that uh, traffic to the corresponding application. So this is the way we uh, like I mean deploy or expose the application using load balancer. So consider this is for a single application, right? For example, we can just grouping a for this two node sorry port, and we call it as a single application. Consider like that we have a multiple application. Coming to production environment, we have a lot of application, right? So I will draw it again. Just assume, okay, we have one more application, app 2. Again, app 2 running in one of the port. So two replicas there, okay. So port 1 and port 2. This is the application, second application, like one of the other application, just assume like that. So how we will deploy, I mean, expose the application using same way, like we need to create a load balancer and pointing, I mean, create a service file, and that service file, inside the service file, we need to define that these are our ports. So route the traffic to the corresponding ports like that. This. Similar way. So this is LB service YAML file, and we need to share the same thing, DNS, right, to the user. So user can access our application via service, right? All of you. So here the main problem is, consider like that, if you have more application, like 10 application or 20 application like that, we have to create load balancer, right? For example, if we have 15 application within the same Kubernetes cluster or same EKS, we need to go with the same scenario. We need to create 15 load balancer, right? So this is not a, standard practice, okay, when coming to application deployment in production environment. Because if we create 15 load balancer, we need to pay more, right? Pay more. All this is very costly because each load balancer we have to pay, uh, like we have to pay, okay. There is a, calculation there when using load balancer. I need to check. So this is a problem is we need to pay a lot of money to AWS to set up in multiple load balancer. The second thing is we don't if you set up similar like a load balance setup, then we can't use. We can't set up a centralized routing logic. Okay, no offering. Coming to this setup, no offering any centralized routing logic. Then coming to SSL management, okay, certificate for setting, installing or generating and installing certificate for the corresponding application. If you go with the similar scenario, SSL management is sometimes the SSL management will duplicate, okay, will duplicating because of a lot of load balancer. So these are the some of the disadvantages, okay, when coming to creating different load balancer and pointing to corresponding application. For a single application, this is fine, okay. For coming to microservice, okay, a lot of microservice we need to set up Ingress. Got it. Ingress is nothing actually. It's a uh, Ingress will, okay. Ingress is a resource, okay, one of the resource in Kubernetes. Similar like there is a lot of other resources are there, right? We learn some of the resources as well, like pod, service, deployment, horizontal pod or scaling. These all are the resources offering Kubernetes, right? So whenever we creating a pod, right, we need to create a deployment. So we need to define the kind. These all the resources we define under the kind, okay? Kind, then we can define the corresponding resources. If, for example, we need to create a single pod, so we need to define the kind as pod. We need to create a deployment, so we need to define as deployment. Similar like Ingress is one of the resource or one of the kind within Kubernetes. So if we define kind as Ingress, Kubernetes know this is for a Ingress. Ingress is nothing. It will routing the incoming traffic to corresponding path or host. It's a route path routing or host based routing. Path based routing or host based using meaning. I will draw the diagram so you will get more idea how the Ingress will routing the path based or host based. Okay, I will set up the same application deployment. So in this case, we will leverage the Ingress as well. So you know how useful the Ingress. So we have two pod, pod one and pod two. So there is a similar application one. Okay, application one. So these are the two ports, and in front of this port, okay. Before that, I will show you how we will implementing the Ingress system. So before that, I will draw the diagram. Okay, the initial first there is a user request, right? A user requesting to access our application. Before the user typing the DNS or the DNS of a load balancer, it hitting the load balancer, and load balancer will routing the traffic to corresponding application, right? So the user request initialize, okay. I mean user typing our load balancer DNS, okay. So there is a load balancer there. So there is a load balancer. This is a service, okay. This is a load balancer to accessing our application. Then in front of the load balancer, there is we need to set up the ingress. Ingress has two part. Okay. First, for setting a Ingress, we need to install Ingress controller. Ingress controller is nothing. We have to install the Ingress controller using Helm. Okay, we leveraging Helm to make it easier to install Ingress controller, because without an Ingress controller, we can't define the Ingress. Okay. So first we need to install Ingress controller. Its control is nothing. It's a controlling system. In backend, actually, what will happen? Whenever we install the Ingress controller using Helm, it will create a port for Ingress controller, okay, within the Kubernetes cluster. And also it will create the load balancer, Ingress load balancer. So this load balancer should create, okay, by the Ingress controller whenever we installing the Ingress controller. So in this case, we don't need to manage manually creating any load balancer for the similar setup. Whenever we installing the Ingress controller, okay, it will automatically create a load balancer for the Ingress controller. So both will set up. So this is actually within the same Kubernetes cluster. We can see some pods are running for Ingress controller. Okay. So Ingress controller is set up. Then again, that Ingress controller pointing to Ingress. Ingress resource, okay. Ingress resource. Ingress resource. Ingress resource is nothing, it's the values, okay. The values. What type of values? Uh First we need to install Kubernetes to set up in SIM, okay. Then we need to install Ingress controller using Helm. So inside the cluster, we can the Helm will install the Ingress controller. So the Ingress controller also install the load balancer for us. Then we have to create the YAML file. The YAML file defining the Ingress resource. So there will be a YAML file, or we can call it as ingress.yaml. So inside the ingress.yaml, we need to define how the ingress is relating to our application, how the routing, like it's a path-based routing or host-based using, and the corresponding application port name, everything we need to define inside the YAML file. So that's why I called the values ingress.yaml values. So everything we need to define inside the YAML file, and we need to apply the YAML file also. Okay. So after that applying, what will happen? The Ingress resource will managing the request, and from I mean it will take the request from the Ingress control and send it to corresponding application. Got it. And how we will access the application? That's the main thing, right? For example, we have a load balancer, right? The Ingress control will also create a load balancer for us. So we need to take the load balancer DNS. So then we need to copy the DNS and put it on some browser. So this is a path base, okay? So we need to put that DNS under the search bar of any browser, then /, then the path name. Path name means we define the path name, all things in that YAML file, right? So for example, this is application one. So DNS /app1. So it will routing the application. I mean, the load balancer routing the application via Ingress controller and Ingress resource to the corresponding port. Then the next question, if we have another application, right? So coming to the another application, okay, we have some other application. And so like that, we have an application 2 there. So 2 port for the application 2, app 2. And these are the 2 ports, okay, port 1 and port 2. So how we will accessing, I mean, how we will expose this application. One of the main advantages of Ingress, okay, whenever we using Ingress, the main advantage is we don't create separate load balancer for any application. Within a single load balancer, we can routing the incoming traffic to corresponding service or corresponding application. So that's the main thing. So coming to if we using Ingress, okay, if we leveraging Ingress in our application deployment, there is we can save a lot of money, okay, because this is a cost-effective setup and it's a typical application deployment as well, okay, using Ingress. So we have we need to deploy another application, okay. The application is deploying 2 pod and 2 services are also there. So how we leveraging the same load balance, okay. Coming to Ingress, we can call it as a shared load balancer. Shared load balancer. We can leverage the single load balancer, okay. We need to only need a single load balancer and we can deploy we can route the traffic to multiple applications as well using Ingress setup. I told you that whenever we install Ingress, right? This is actually offered by, okay, Nginx. We called as Nginx Ingress control, okay. So this is actually Nginx Ingress controller. Okay, so in this case, what will happen? What we need to do? We have a resource file, right? The YAML definition. So just open the YAML and we need to add that corresponding applications setup there. For example, we have to deploy other application like app2. Okay. So inside the YAML, we need to configure that path and everything. So what will happen? We have the DNS, right? Load balancer DNS, then / app2. So that application goes to like to the second application. If you have app 3, then similar way, app 3. So the path we need to change, okay? So it will go to A3 like that. So the benefit is we have to set up a single shared load balancer and load balancer will share in this setup. Got it, all of you. Anyone have any doubt?
We are leveraging.
Sorry, come again. You're breaking.
I am hearing the echo actually. So we are using the Helm chart to define this.
Yeah, Helm start to install Nginx Ingress controller.
Okay.
Right.
Then it will create all the service or the deployment or the value, whatever the value dot
Right, right, right,
files. We
right.
need to
Ingress.
update those files, right?
Right, right.
Okay. But like, how about the host base? Maybe the DNS, whenever there is an uh,
If we have host space, then we will define the host as well, coming to the path instead of path.
path. Okay. Got it.
Host base means, for example, path base means we need to define the path. I mean, the application. Okay, we have to define that everything in the resource YAML Ingress resource YAML file. So if we are using host based routing, there is a definition like host. Then we need to define that app to.example.com, similar like, or else we can use API. Here we can define the API if using any API type routing, similar like we can define under the host. Path base just define the path name only. Okay. Host, we need to define the host domain name actually. app.example.com. For example, we for a single application, we had different type of hosts, right? So we need to define that as well here. Or else we have multiple domains set up there. For example, abc.com. So that's the one of the application. Okay. Then bca.com. Then is another application. So we need to set up these are one host and this is another host. So inside the YAML definition, we need to define the both hosts there. So it will, I mean, the Ingress resource will do the host-based routing. It's actually managing the incoming traffic. Okay, that Ingress controller will manage the incoming traffic and what are the definition that we define in the YAML manifest of Ingress resource. Okay, it will routing corresponding to the path or host similar way. Just by heart that workflow. That's enough for that Ingress setup. Okay, like a user first the user request, right? User request on the browser, then it will hitting the load balancer. In our case, it's a elastic load balancer, right? Because elastic load balancer offered by AWS. Then this will create by whom? The Ingress controller. Whenever we installing the Ingress controller, it will create. I mean, the load balancer will create, okay? Ingress controller by Ingress controller created by. So there is a load balancer there. And the next thing is goes to Ingress controller. In this case, we using Nginx Ingress control. Okay. Then it goes to the Ingress resource. So inside the resource, it's a YAML definition. So there is a rules there. That rules include that the application, I mean the path base or host base like that. So everything we define that file. Then after the Ingress, the request goes to the service of our application. Okay, for example, we have application one, right? Whenever we running or applying the application one YAML manifest, we need to set up the service for the same. Okay, service in this case, the service is not load balance or anything. It will be the cluster IP or anything like that. So then it goes to the service, then it finally hitting our pod, the application. This is a service dot, for example, application one service, application two have another service like that. Then it will hitting the application one pod. This is a, I mean, workflow of Ingress. Oh, I mean, after implementation, okay, Ingress. Got it, all of you.
Okay. In the rules, can we whitelist the IP addresses or something like that? Is there a way in the Ingress?
Means I didn't get you.
Whitelisting, allowing
Whitelist.
only few, yeah, whitelisting.
You mean IP, right?
Hmm.
Yes. Instead of IP, all things we define as a host. For example, abc.com. This is a domain name, right? For the same domain, there is a IP there, right? Instead of IP, we define the domain name as host.
Okay. Suppose if I am the person who has only need access to that one, so I can give my IP address, like whitelisting my IP address, and I can access that one, right? That's
Yes,
what.
yes, whitelisting there, whitelisting there.
Okay.
So you can jump to the lab, right?
Sure.
So everything is up and running. Okay, fine. I have some sample application. Okay. So I think that is on CDTM.
Don't you need to update the kubeconfig file?
No, whenever we installing that AWS CLI, okay. So it will automatically take in that kubeconfig file. I will check cat. See, the config file is here. We don't need to, update the context sometime because we're using AWS CLI. Okay, that's our three dependencies. First AWS CLI, then EKZTL and kubectl. If you sometimes we facing some issues whenever typing the kubectl, at that time you need to update that context, the kube config file, cap config. So this is a file actually. So in this case, we don't need to update anything.
Okay. Are you searching for YAML?
Yes.
We didn't go with this one, right? What we call Helm chart.
Mm, Helm chart.
We need
Yeah,
to
we don't install
install.
anything actually. Before
Yeah.
that, yep. So for example, there is no code here, right? See, kubectl, git pod, nothing here. Kubectl, SVC, we can see a single SVC there. Only Kubernetes, right? So
Mhm.
first we need to install the no, Ingress controller using Helm. So some using Helm, we need to run the Helm command. Okay, I think Helm is installed.
LM. HELM. Helm version hyphen client. Space.
Okay, Helm is installed V17. Now, after the installation of Helm, we can directly run our commands. Okay, Helm commands. So these are the commands. Helm add repo. First, we need to adding the Helm repository for the Ingress. Okay. Then we are updating the Helm repo update using second command. This is the first command, and this is the second command. So in this case, it's already exists in this my machine. So that's why already exists with the same configuration. So skipping. Now we have to install the corresponding Helm package. Okay, in our Kubernetes cluster. So before that, we need to create a namespace using kubectl namespace in Ingress and Nginx. Then using Helm package manager, this is a command Helm install Ingress and Nginx. Then the file, I mean the repository file name we need to define. Then the namespace we need. So what will happen? The Nginx, sorry, Helm will take that package. Okay, that YAML package for Nginx Ingress control and install in our Kubernetes namespace in Ingress Nginx. So that's fine. Now I'm going to run some commands. Okay, kubectl get svc. See
We have a
that.
namespace.
Uh, okay, give me a second. Namespace Nginx. Oh, sorry. We have to. Give me a second. Encrypted. We have to apply the YAML manifest. Okay. So to source YAML manifest after creating load balancer. Click again. Nginx. Windows. Sorry, it's installed. Okay, load balancer is installed.
-n.
Hmm. So it's installed. See, this is the load balancer for the controller. So before that, there is no namespace and there is no load balancer. So the controller, we successfully install the controller, and the controller already created a load balancer for. Now we have created the YAML manifest defining the application. Okay. So we need to create some sample application. I have some application. I missed that file. We'll check again. Mm, Okay, leave it. We can go with the creative files. Okay, I'm going to create two application deployment sample YAML manifest. Nano app. Yeah. So this is a simple application file. Okay, to expose some application content, and it will create a application port. So this is an application service. Okay. So it's nothing, we did not define any service type in this service file. So if we don't define any service type in our service file, which service automatically create, that is class type. Okay. If we did not define any type, or else we need to define cluster IP or dot port or load balancer, similar like. If we did not define anything, it will create a cluster IP. So this will create a application deployment. Okay, so creating a deployment file, and here we need to change app one. This is for app one. Okay, so here you can, there's the image. This is just a echoing something. Okay, HashiCorp HTTP image. We using that one. So using that image, we can echo something. So what are the text that we need to echoing? We need to define here. Okay, so this is the content it will display on our when we access the application. So the image HashiCorp HTTP demo using port number 5678. So that's why we define the port number also in container path and argument. Okay. Save and exit. Similar way, we need to create application 2 as well. Okay. Tender. I'm using the same file. So the content is app 2. Okay. On the previous one, it's app 1. Save and exit. Now we can directly apply both file. kubectl apply app1.yaml. Both are apply. Okay. Define the file name. That's fine. app2.yaml. See, both created kubectl get pod. So our application is running. Both applications running. Okay, as we see. So there is no there's a service file created for the both application, and you can see the type as cluster IP. See, app1 and app2. There is no external IP or external DNS for accessing our application. Now we have to create the last part, Ingress resource or Ingress YAML file. So nano Ingress .yaml. So inside the ingress.yaml, we need to define that how that application routing, like similar like that. Okay. Everything we define under here. So it will creating, uh, see the kind as Ingress. Then the name for the Ingress we need to define demo Ingress. So that's the name for the Ingress. And under the annotation, we can see it's using, this is a Nginx Ingress. So we need to define Nginx.ingress Kubernetes rewrite target. So this is the annotation, okay. And coming to the spec, Ingress class name. This is Nginx Ingress controller, right? We're using a Nginx Ingress controller. So in the class type is Nginx. So we need to define like that. Then this is the main part, okay, for the application one, and this is for the application two. How we will path-based routing define inside the manifest. So the HTTP, then we need to define the paths. Under the path, we need to define the path. So the first application, okay, that is app one. We already applied, running application one, right? So this is our path for accessing the application one. We can change, okay, what are the name we defined there, then we need to define it here, okay, same way. So this is the name of our pod. How this specific service related to the application pod. So the application name we need to define here. So same name define the YAML manifest of the application one. This is the application name, okay. And for that, we need to define the port number as well for the specific application. So both are using port number 80. Then for the same, we need to define the second application. Two, this is a path to access the application, and the container name or the application name is defined here. So the Ingress resource will take in the application and routing using the path base. Now we need to run this as well. kubectl apply. Before that, I will show you, okay. I will take that DNS that created or not controller, okay. Ingress. See, this is the Nginx error, but that Nginx, this is Nginx 404 founder, okay, because that Nginx Ingress controller can't find our application. The pod or that path app one and app two, because we did not apply the file, right? So we need to apply the file. The name is ingress.yaml. So here you can see Ingress network.io demo Ingress created, the name for the demo. We can check that Vassal kubectl get Ingress. So here we can see the Ingress name, then the class Nginx host, the port number listening, everything we can see here. Now we need to back to the portal and refresh. We can't see anything, but this is a path based one, right? So we need to define the path as well. App one. See, hello from app one. Now we need to change the application, right? So path change app two. See, so the single load balancer will share the incoming traffic to multiple services. Got it. Otherwise, we need to define two load balancer DNS here, and it will we need to create different load balancers within the same system. See, go back to the AWS console and we can see that load balancer as well. Anyone have a doubt?
No doubt,
Here we
sir.
can see, yeah, a single load balancer here. So the single load balancer will taking the load and routing the traffic to multiple host or path using Ingress controller. Got it. So if we have more application, what we need to do? Just edit that Ingress file, right? So we have Ingress file. So we need to edit the Ingress file and define that we have one more application, then this is a path or this is a route like that. We need to route to the third application, similar way. So this is the common typical application deployment, okay, using Kubernetes. We mostly using Ingress for routing applications, multiple microservice application. So anyone have any doubt?
So for the EC2, did you take the instance type as T2 large for this one?
No, no, no. For this mission is single mission. We don't do anything, right? Only we install LM and the dependency for managing Kubernetes. So this is a T2 micro mission.
T2 micro only. Okay.
See,
Okay.
most of them are Kubernetes node. So that is T2 small.
So how do we delete this ingress one? Just cluster. If you delete the cluster, it will go off or
Yes, no doubt from here, right? So shall I
mm,
delete the cluster?
yes.
ekctl delete cluster. Then the name of the cluster. We need to
Cluster
define
and
the
region.
name. Anyone know the name?
Ingress.
Ingress, right?
Yes.
Ingress something. Ingress test. Dash
Yes.
test, right?
Yeah.
Okay. Otherwise,
Region.
we can check that command ekctl get cluster, then define the region. So it will list the cluster details within the same region. Then ekctl delete cluster name, then the region. Just used to one. So whenever we type and hit the no cluster there, right?
Cluster name is
I think no dash here, right?
yeah. Maybe. Mhm.
Yeah.
Yes.
So now it's starting to delete the entire thing, including the load balancer. So we don't bother about anything. Including load balancer means what are things it created? It will create a dedicated VPC for that cluster. Then NAT gateway, lot of things are there coming to the network part. VPC, route table, subnet, then the NAT gateway, static IP. Then coming to the master part, it will creating these are the the machines. Whenever we're refreshing, it will take some time to remove that cluster. First it will creating that things that created last. Okay, we can see the load balancer will deleting like that. Rubase. So everything will removed. Okay, these all the machines, these are the nodes, right? So these all the node will terminated by ekctl tool.
Can you search for like the service cluster? Um, uh,
Kubernetes, right?
yes.
It's not deleting it. It's starting to delete, but it will take a lot of time.
I know. I'm just want to see
Still
like
it's active.
we can get the name from here to write.
Right, right. Or else we need to type ekctl get cluster the region. That's a command to search from command line. I think it started to remove node group. Yeah, see, first machine goes to shutting down state. It will take some time actually.
We didn't define the node group name, right, when creating the cluster. So,
No. By default, they will create a group actually.
okay. So
Or
if we
else we
want to
can.
define, if we want to, we can give the name.
Right.
Okay. You can go to CloudFormation template. It will go and show you everything. It's deleting.
Right. That. Okay. Right. Okay. So anyone have a doubt regarding
So
the Ingress?
after cluster gets deleted, then only we have to shut down the EC2, right?
Right.
So if we like do it without deleting the cluster, if we delete the EC2 instance, then
Then
we
we need to
have to manually delete.
manually,
Okay.
or else we need to set up another machine and take in that qconfig file. That's all.
Okay.
Yeah, we have the role, right? We have the role to managing Kubernetes cluster. So if that machine does not have the role, we need to attach the role to describing EKS machine or EKS node to.
So for these two, you have attached the IAM role for this EC2
Yes,
instance.
yes.
Okay.
For the same machine, I attach the role. Without the role, we can't do anything, okay? Because role is the must thing coming to. This is a same mission I used to do before. So here we can see under security,
Yes.
the EKS admin attached.
Okay.
So everything is good. We can wind up, right? All of you.
I'm good.
Okay.
Sure. Thank you for the class. Have a good night, everybody. Good morning, Tawfiq sir.
Bye. Bye all.
Bye.